In this video, we're going to be thinking of the idea of work, sometimes referred to in physics as work done. In everyday English, work has got many meanings, of course, but in physics it's very specific. It's referring to energy that has been transferred. Now, remember in the previous videos we've talked about energy changing from one type to another. Well, that's what we mean when we say work done. Energy is measured in units called joules, so work is also measured in units called joules. At GCSE level, a good tip is if you see the word work or the phrase work done in a question, in your mind replace that with the word energy and you won't go too far wrong. Now, going a little bit deeper into this topic, work done specifically refers to work that is done when a force moves something. So it's not really just talking about any old energy transferred. It's talking about the energy that's transferred when a force pushes or pulls something over a distance. And there's an equation for this. The equation for work done is the force that was doing the pushing or the pulling multiplied by the distance over which the object moved. Force is measured in newtons, distance is measured in meters. Interestingly enough, when you multiply newtons with meters, we end up with joules over here. So let's do our first question with work done. You push a supermarket trolley with a force of 50 newtons along a distance of 3 meters. So how would we calculate the work done? Well, first of all, we would write down the equation. My advice is to always write down the equation before you put any numbers in. Now, we know that work done is the force that was applied multiplied by the distance that the object was moved. So then we look back at the question and we read the values that we need. Well, the force was 15 newtons. The distance was 3 meters. Remember to use meters. If the question gives it you in centimeters, you nearly always have to convert it into meters before you put it into the equation. So just be a bit careful there. And the answer, of course, 15 times 3 is 45 joules. So in other words, by pushing that supermarket trolley with 15 newtons along a distance of 3 meters, you did 45 joules of work. Now, what that also means is that 45 joules of energy was transferred from you into the trolley. So imagine you've pushed it for 3 meters and you let go, and the trolley continues moving, then the trolley has gained 45 joules of kinetic energy. So remember, the work done is the energy that you've transferred into something, and in this case, it was transferred into kinetic energy. Some questions, however, don't just involve pushing or pulling something across a surface, horizontal motion. Some questions include lifting an object, i.e. vertical motion. Well, in any question that involves lifting the object, the force that we use in our equation is always going to be the object's weight. So for example, if the equation for work done we now know is work equals force times distance, I'm just abbreviating it there by putting in the letters, the force that we would use if the object was being lifted vertically would be the object's weight. Now, how do we calculate weight? We will go into this in more depth in a later video. But for now, it's enough for you to know that weight of an object is the object's mass multiplied by 10. Mass is always measured in kilograms. If you multiply the mass by 10, you get the weight, and the weight is measured in newtons. So the weight equals mass times 10, and it's that weight that we use as the force in the question. Here's an example of a question where the motion is vertical and not horizontal. It's not pushing something across a surface, this is actually lifting something, raising a mass. So the question states, a person with mass 75 kilograms walks up the stairs of a tall building of height 400 meters. How much work was done? Well, we know the equation for work done. The equation for work done is force times the distance. Now, we know that in this type of question, when it's a vertical question, when something is being lifted, we must use the weight for the force. Now, we know that the weight of something is going to be equal to its mass times 10. It's very important not to confuse the terms weight and mass. We'll do this later in another video, but for now, just keep them very separate. And remember to convert, you just do weight equals mass times 10. Mass is in kilograms and weight is going to be in newtons because it's a force. So if we look at this question then, work done equals force times distance. So work equals the weight times the distance. Well, the weight is going to be 75 kilograms because that was the mass, times by 10. And then we're going to multiply that by the distance. Well, that distance is the height of the building, 400 meters. So what we're left with there is something that looks like this: 750 times 400. Now, it's up to you. You can use a calculator for this sort of question. In fact, if you struggle with maths, I would advise you to use a calculator. There's no point losing marks just on a maths mistake. But you can do this without a calculator with a bit of practice. What we will do is we'll do 75 times 4 first, which gives us 300. And then we've got 1, 2, 3 more zeros, so we just stick 3 zeros on the end, like that. And then we've got the units, which are joules. So the work done in this situation was 300,000 joules.